Alright, so the last lesson in this first module is 114, which is on credit card numbers. So, of course, this is something that's highly relevant to all of us. So, kind of like the problem or the lesson before, we kind of skipped over a few paragraphs. I kind of set up everything. But here's everything that we need to know about a credit card number. So the first digit indicates what kind of credit card it's going to be. So if you kind of look right here, the 4 and 5 are used for banking and financial. So Visa cards always begin with a 4. MasterCards always begin with a 5. After that, we have the issuer identifier, so that's the next 5 digits, and then the account number, which is the next 9 digits, and then we have a check code, kind of like what we saw with our universal product codes to help ensure that this is a valid credit card number. So number one's a good question to start off. Kind of goes back to a lesson that we had before, but it's asking what's the total number of credit cards that MasterCard can issue. So this will be excluding the check digit, which relies on its value for others, and will only have one option. So we can keep that in mind for a check digit. But it tells us that MasterCards, they of course start with a 5, and then the second number can only be one of 5. So there's going to be 16 digits total. So 1, 2, 3, 4. Set it up like this. So if we're talking about MasterCard always starts with a 5. As we can see here, this next digit is only going to be 5 digits, 1, 2, 3, 4, 5. As for all of these others, it doesn't give us a limitation or a restriction. So we can assume that that's going to be any single digit number, and there's 10 single digit numbers. So we're just going to have 10 for all of these, all the way across up until the very end. Your last one's check digit would only have one option, so 1's going to go there. So if we multiply all this together, we're going to figure out what's the maximum number of credit cards MasterCard can issue. And if we kind of just simplify it, there's a lot of 10s there. There's 12 to be there, or actually 13 to be there. But 1 times 5 times 1 is 5 times those 13 10s there. So that's going to be a very, very large number. So we shouldn't, or MasterCard shouldn't be in a situation where they're running out of credit cards soon, as this right here represents the total maximum of cards that they can have. So let's take a look now at the math behind this to prove if this is going to be or if the credit card numbers we have are going to be valid. Alright, so if we read through, it says our check digit helps validate our credit card numbers. So they use the COBAR method, which is used to determine our check digit. So here's what the method is. We add the digits from the odd positions and double this number. So this is a little different compared to our UPC numbers, where we multiply by 3. Instead, with our odd numbers, we're going to multiply those by 2. So odd placed, we multiply by 2. I'm going to come back to this dot, or that second dot, but our third dot tells us that we add all of those even ones to the total. So just like before, our even placed, we just add together. Where this gets a little different and interesting is the second dot right here. So let me highlight it. It says add the number of odd position digits that are more than 4 to the total. So what this is saying is that with all of our digits in the odd position, we're going to get a number of those that are greater than 4. And then with those, whatever number that is, how many ever numbers in the odd position are greater than 4, we add that to our total, or to our final calculation. So the way that's going to look like in a problem, we need our odd position numbers, or our odd placed numbers. Switch to color up here. We need what I'm going to call our odd placed that's greater than 4. So we'll get all of those numbers. And then lastly, we'll get our even placed numbers. So I'll kind of skim through our even and odd placed numbers. We should be able to figure those out since we just did that in the lesson before. But since I already have the read out, if we go and add all of our evens together, here's the numbers for that. So we're looking for the check digit to prove that that is a 3. Let's go and look at our odd place. So we're going to have 2 times that, so it's going to be multiplied right there by 2. And then here's all of our odd placed numbers. Okay, so the problem is asking us to figure out what the check digit is going to be. Would be important to know, as I should mention, final digit is going to end in 0. So it's just like the method that we used before where we want to end in 0. So 70, 80, 90, 100, so on and so forth. As long as it ends in a 0, it's good. So it's asking us to prove that 3 is supposed to be that number right there, so we can show that that is a valid credit card number for Visa. So like I said, the odd and even, we should be able to separate and distinguish those two because that was in the lesson before. But where it gets a little more interesting is figuring out our odd place by 4. So if I look at my parentheses right here, put a line on top of it, all of that stuff right there, I need to get all of the numbers that are greater than the number 4. So if I just go across, 4 itself is not greater than 4, so I wouldn't count that in my little list here. But this 6 is, so I'm going to have the 6 right there. That's 6 greater than 4. The 0 isn't, the 1 isn't, the 3 isn't, the 5 isn't, but this 7 is. I'm sorry, the 5 is. Skip that one. The 5 is greater than 4, so I'm going to write a 5 right there. The 7, that next one in line is, and then the 9 is as well. So in that parentheses of all of our odd place numbers, there's 4 of those that are greater than the number 4. So when I go through and do my math on this, that odd place, when I do the math, add all that up, multiply by 2, I get 70. Let's get our even place. When I add all of that up, I'm going to get 23 plus the check digit. So all of the numbers I have, when I go through this, there's 3 numbers I'm going to get. I got the 70 from my odd placed. I have 4 because there's 4 odd place numbers greater than the number 4, and here's each of those that do that. And then I have my even placed. So now I'm going to add everything together and figure out if this check digit is going to be 3. So I'm going to do that down here. So I got 70 plus 4 plus 23 equals the check digit. So when I simplify all that together, I'm going to get 97 plus whatever my check digit is. I need it to be 3. So of course it makes sense that if this is 3, as it says right there, I get 100, which is what I want. So here's a problem right here of us going through and doing a check digit for a credit card. Alright, with 3 and 4, I want you to try these problems on your own. So we'll take it one at a time. So number 3, just like the problem before, we need to figure out what our check digit is going to be. So with that, I need my odd placed numbers. I need you to go and get those. We need our odd placed, how many of those are greater than the number 4. And last but not least, our even place number. So I want you to go through and do this and figure out what our check digit is going to be. So pause and do that. Okay, so when we split everything up, this is what we get. So there's your odd place numbers. There's 3 of those, that 5, 9, and 8, that are greater than the number 4. And then you have your even place numbers down there. So once again, we're looking for the check digit. So right here off to the side, here's my math to get that. I add everything up. I'm going to get 87 plus the check digit. The check digit would have to be 3. So if it ends in 7, I need to add 3 to that to get it up to 90, which will be my number that ends in 0. So last thing is number 4. So this time we're going to prove that it's invalid. So this time actually even easier. We don't have to worry about finding a check digit. So I want you to try this problem. We'll talk about 5, and that will wrap up this lesson. All right, I should mention that in the problem before, I forgot to write out that I multiply the odd place by 2. You do get 58, so when you add all that up, you'll get 29. Multiply that by 2, and you'll get 58, but I forgot to show that there. Well, looking at problem 4, I do have that set up this time. You do multiply that by 2 there, but you're going to get 40. You should get 1. There's only one number that is, or one odd place number that's greater than 4, that being 8. And then 24 for the odd place. When you add that up, you get 65. So we should see that that's basically right down the middle, not a number that we want to prove that it's valid. It is, in fact, invalid because it does not end in a 0. And the last question we're going to look at here is number 5. So it says, if someone made a single-digit error when entering this invalid number, can you tell which digit is incorrect, why or why not? So this is just like the question that we had for the UPC. We cannot tell, so no, we can't tell, because any digit can be increased or decreased. So we can't tell exactly which digit in that credit card number is wrong based off of the 65 that we got. We know that there's some adjustments that we could make, probably to the evens, to make it work out to be valid. But we don't know specifically which number is incorrect. So it's going to wrap up our last lesson of Module 1. This one's on credit card numbers. So hopefully we see the similarities to the Universal Product Code lesson. And like I said, it's going to wrap everything up for this module here.